In today's video, we will look into one of the Gauss contest questions from 2007 for grade 7. Let me read the question. In the multiplication shown, P, Q and R are all different digits so that PPQ times Q is equal to RQ 5Q. What is the value of P plus Q plus R? Let me zoom in the multiplication. We need to find P, Q, R. For those who want to try on your own, please pause the video right here to try. Others, please stick around. So basically when we are doing the multiplication, we always start from left to right. Alright. So here it is Q times Q is equal to Q. So basically this is going to be the same number. When it's multiplied with itself, it gives the same number. So when you think of those options, the probabilities, you get either it's going to be 1, or it's going to be 5, or it's going to be 6. Since 1 times 1 is 1, ending with 1, the same number. 5 times 5 is 25, which ends with the same number 5. Same way, 6 times 6 is 36, which ends with the same number 6. So in this, I'm going to rule out this option 1. I'm not going to take out option 1. So let me take the option 5 as of now. Okay, so 5 times 5 is 25. Alright, so Q is 5. I'm going to assume this, carry over this 2 since 5 times 5 is 25. Now, what times 5, that is P times 5 plus 2 will give a number ending at 5. Now, when you reduce this 2 from this 5, you get a number ending with 3 basically. So we need to find a number that ends with 3. So P times 5 ends with 3. So normally when you look into the 5 times table, there is no such number that ends with 3. Alright. So what we assumed that Q is 5 is wrong. Okay. So let's rule out this option as well. So I'm going to rule out this 5 and I'm going to use this option, which is Q is equal to 6. So 6 times 6 is 36. So I bring the carried over 3 here. Alright. So now P times 6 plus the added 3 is equal to a number that ends with 5. Alright. So when you think of that, when I reduce this 3 from this number ending with 5, it becomes a number ending with 2. So basically we need to find P times 6 is a number ending with 2. So when you look in that 6 times table, it can be either 6 times 2, which is 12, or it can be 6 times 7, which is 42. So P can be either 2 or 7. Alright, so I'm keeping the option 2 or 7. It can be any option here for P. And Q is 6 right now. Fine. So first I'm going to assume this 2 here. 2 times 6 is 12, and when you add the carryover 3, it becomes 15. So I have the 5 here down. Alright. So, and I move the 1 carried over here. This P is 2, then I'm sure this P is also 2 since it's the same. Now again 6 times 2 is 12 and the carried over 1 is there, so it becomes 13. So I get 13 as the answer here. But when you look in the answer, the Q is same, right? Here the Q is same, but you have different options, different numbers. I get different numbers. I assume Q to be 6. I should get Q as 6, but I get it as to be 3. So basically this is wrong. So what I'm going to do, I'm going to rule out P to be 2. I'm going to rule out this. So I'm left with P as 7 and Q as 6. Now let's start over the process. I'm going to assume Q to be 6 in the same way. So I get 6 times 6 is going to be 36. And I'm going to assume P to be 7. So 6 times 7 is 42. And 42 and 3 added to it to become 45. I have the 5 here. And I'm going to take the 4 as carried over. Alright. Now, since this P is 7, this P is also 7. So 7 times 6 is again 42. 42 and 4 added to it will become 46. So now when I look into the answer, I have two Q's here and here, and I assumed Q to be 6 here. So I get the same 6 for the first Q and the second Q as 6. I get the same number. So I can assume safely P to be 7 and Q to be 6. And then what I get from R, for R this is 4. R is 4. So I can assume R to be 4. Fine. So P is 7, Q is 6 and R is 4. Now that we know the values of PQR, which is 7, 6 and 4, we need to find P plus Q plus R, which is so easy, damn simple. 7 plus 6 plus 4, and that's equal to 17.